Hello, my dear friends. What's up? I hope you all are doing well. So today, here we are to discuss a very important topic, that is current electricity, with the help of 13 very important formulas that you can see on the board. So this is a quick revision of the complete topic current electricity with the help of 13 important formulas. Let us start very quickly. First comes electric current. So what is electric current? Electric current is the rate of flow of charge across any conductor. If this is a conductor and delta q charge is flowing across it in delta t time interval, then current I will be equal to delta q by delta t. This will be average current, this is charge, and this is the time. So rate of charge flow, this can be given I average delta q by delta t. Now if we have to find instantaneous current at any particular point of time, then we will take this delta t very small, infinitesimally small, that is delta t tending to 0. So I instantaneous will be equal to limit delta t tending to 0 delta q by delta t, that is dq by dt. So this is the another formula for instantaneous current. Okay, next, see, if n is the number of electrons per unit volume of this conductor, then in 1 second if drift velocity is vd, then what will be the rate of charge flow across this conductor? So the charge moving across this conductor in 1 second will be n per unit volume into volume, that is a is the cross section area, this into vd, that is drift velocity into, so this will be the number of electrons, and into E, that is charge on the electron. So this will be the current N E A V D. Here you can see this I is equal to N E A V D. Now what is the value of Vd? See, in any electric field E, the value of Vd can be given by E, capital E by M into tau, where tau is the average relaxation time and E is the electric field, small e charge on electron, M mass of electron. So here you can see. Next is current density, that is the electric current per unit area, I by A, NEA VD by A. So this will remain NEVD. This will also be equal to current density is directly proportional to electric field. So this, if current density is directly proportional to electric field, that will be J is equal to sigma E, where sigma is the electric conductivity. This is a specific property of that material. Now comes Ohm's law. So what is the Ohm's law? Just a minute. Ohm's law says that voltage across any conductor is directly proportional to the current flowing through it. So if this is a conductor, then voltage across, let's say this is VA and this is VB. So voltage across this conductor will be VB minus VA delta V, is directly proportional to current flowing through it. That will be Ri, where R is the resistance of that conductor. So here it is, this R is the resistance. Now R is directly proportional to length. If length is larger, then resistance will be increased, and if cross section area is smaller, then also resistance will increase. So this is directly proportional to L by A, that can be rho L by A, where rho is the resistivity, that is the specific property of this conductor material. This is conductivity. So here you have another formula, that is, and this rho resistivity will be equal to inversely proportional to conductivity 1 upon sigma. So resistivity will be equal to 1 upon conductivity of that material. Now dependence of R on temperature, let us see. R will be equal to R reference 1 plus alpha delta T, that is T minus T reference, where T is in degree centigrade and this alpha is temperature coefficient. Now see, if reference temperature is 0 degree, let us see, then R will become R at 0 degree 1 plus alpha and temperature of that conductor. So here you can see this equation. Now comes electrical power. So what is the power? Electrical power will be equal to V, voltage across the conductor, into I. Basically, you know, I is dq by dt. and V dq will be work done by dt per unit time. So from here we will find Vi as the power. So this can also be written as I square R, that will be equal to V square by R. So this is the power. Now what will be the energy, electrical energy? This will be P dt power multiplied with time. So this will be equal to V I T R I square R T, that will be V square by R T. So here you have formula for electrical energy. Now comes Kirchhoff's law. See, first comes junction law. So what junction law say, or current law? Sigma summation of I incoming is equal to sigma summation of I outgoing. That is basically conservation of charge. Means if here it is a point P and there comes in any circuit I1 current, I2, I3, I1, I2, I3 are incoming currents and I4 and I5 are outgoing currents. So by conservation of charge, incoming current total I1 plus I2 plus I3 will be equal to outgoing current, total outgoing current, that is I4, I5. And if it is I6, I7, then this will become I6 plus I7. So I hope you got it. There is no issue here. Now comes loop law or voltage law. So net potential drop across any closed loop will be 0. So if this is the EMF of this battery or cell, I current is flowing through this closed loop. This is a resistance R1, this is R2, this is R3, I2 is I is the current in this circuit. So we will move in either clockwise or anti-clockwise. From here let us take anti-clockwise. So the potential drop, summation of potential drop will be equal to 0. From here this is minus, this is plus, so we will start from minus terminal. This will be minus E, EMF of the battery. Then potential drop across R1 will be I is going from in same direction, so this will be positive IR1 plus again IR2 plus again IR3, that will be 0. So E will be equal to I R1 plus R2 plus R3 I hope there is no issue. Very simple. Also, you are familiar with all this. So, this was our junction and loop law. Now comes combination of resistances. So, resistances in a series, if there are R1, R2, R3, so on, Rn between terminals A and B, then the net, if equivalent resistance is R, then R will be the summation of R1 plus R2 plus R3, so on, Rn. This is similar case as just we have drawn a figure for Kirchhoff's loop law. So this was the case there. Now you can derive it from there only. Now if resistance combination, resistances are in parallel combination, then here it is A, here it is B, R1, R2, R3, Rn. This is a parallel combination of resistances. So this will be equivalent to A, R equivalent B. So here 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus so on plus 1 upon Rn. We can derive it also very quickly, but this is a revision clause, so we will move ahead. So this was combination in series and parallel of resistance. Now comes Wheatstone bridge. Okay. So what is Wheatstone bridge? This is like this. This is galvanometer connected between these two terminals. Then there is again, they are connected with terminals A, B, C, D. The galvanometer is connected between B and C. There are resistances R1, R2, R3, R4. Here the battery of voltage V is connected between these two terminals A and D, and galvanometer between B and C. So VG or say VBC, potential difference across these two terminals upon potential difference across these two terminals, that is VAD is equal to V. This will be equal to R2 R3 minus R1 R4 divided by R1 plus R3 multiplied with R2 plus R4 at any general point. But in specific case of balanced Wheatstone bridge, the current across here this galvanometer Ig becomes 0 in a balanced Wheatstone bridge. So if Ig is 0, so Vg will be equal to also 0 as V is equal to IR. So from here, if this is 0, then this is also 0. So R2 R3 will be equal to R1 R4, or we can say R1 by R2 is equal to R3 by R4. R1 by R2 will be equal to R3 by R4. Similarly, we can also say R1 by R3 will be equal to R2 by R4. Now in an experiment, if here we are given length of this AD, let us say length of AD is equal to L, say 100 meter. From here we also know that resistance is directly proportional to length. R is equal to rho L by A. So if area of cross section and resistivity are constant, then R is directly proportional to L. So we can also write it as R1 is equal to R3 into R2 by R4 will be equal to L2, length of resistance, to L2 by L4. Using this formula, you can find the value of R1 if R3 is given. This R3 is given, we can find this value R1 if length of these two are given. So this was a quick revision. You all know this. This was balanced Wheatstone bridge, Ig0, Vg0. We have found this. Now combination of n cells. So cells in a series. These are n cells. E1 EMF E1, internal resistance R1. This E2 EMF R2, internal resistance. Similarly E3 R3, En Rn. A B. So this will work as a equivalent battery with EMF E equivalent and internal resistance R equivalent. Again, series combination. So R equivalent will be equal to R1 plus R2 plus R3 plus 1 Rn. And E equivalent will also be equal to E1 plus E2 plus E3 plus En. So this is the case for both E equivalent and R equivalent will be the sigma R and sigma E. Okay. Also remember to write E1, E2, En with their polarity. Like if this is plus minus plus minus plus minus, so current here flow I. So if we take E1 positive here, then E2 will also be positive, A3 will also be positive, En similarly. But let us say here it is terminal, this is negative terminal, this is positive terminal. So this is opposite case in compare to this. So here we will be equivalent E1 positive, E2 positive, here E3 was also positive, but now here E3 will be negative, opposite direction, plus so on, plus En. I hope you got it. So you will have to remember write EMF with polarity in this case. Next, in parallel case, parallel combination of cells, internal resistance this will be equivalent to cell E equivalent, R equivalent, this is E1 R1, internal resistance R1, E1 EMF, E2 R2, E3 R3, En Rn. So again parallel combination, so 1 upon R equivalent will be equal to sigma 1 by R, n will be equal to from 1 to n. So this will become 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on, 1 upon Rn. And A equivalent will be here sigma E by R upon sigma 1 by R. What is E by R? Basically E is equal to IR. So this is E by R is basically current. This will be equal to E1 by R1 plus E2 by R2 plus E3 by R3 plus so on, En by Rn by this R equivalent 1 by R1, 1 by R2, 1 by Rn. To remember this formula, you can equate it with this with E is equal to IR I can be written as E by R, and this will also be IR will be equal to I upon 1 by R. I is equal to sigma by R upon 1 by R. So for n number of cells, this will be summation of sigma by R upon summation of 1 by R. I hope there is no issue. Again very simple, also very interesting topic. So here we revised the complete current electricity topic with the help of these 13 formulas. This will be very helpful in your upcoming exams. So mark up these 13 formulas to solve any problem related to this topic very quickly. This was the purpose of this video. I hope you enjoyed the discussion and you will be benefited with this discussion. If you have any query, you can write in the comment section below. So thank you.